You are floating in the void of space. Your blood is boiling, the radiation is shredding your cells, and the cold is freezing you solid. For you, this is death in seconds. But for one animal on Earth, this is just another Tuesday. And the scariest part isn't that it survives, it's how it does it. The indestructible water bear. You are floating in the void of space. Your blood is boiling, the radiation is shredding your cells, and the cold is freezing you solid. For you, this is death in seconds. But for one animal on Earth, this is just another Tuesday. And the scariest part isn't that it survives, it's how it does it. This is the tardigrade. Found in the most humble places on Earth, from the moss in a backyard to the sediment at the bottom of a lake, this creature looks more like a microscopic gummy bear than an indestructible titan. At less than a millimeter long, the tardigrade, often called the water bear, is a chubby, eight-legged animal that ambles through its world with a slow, endearing clumsiness. But do not let its harmless appearance fool you. This creature is a master of survival, possessing a biological superpower that borders on magic. When faced with an environment that would kill nearly any other life form, the tardigrade activates a state of suspended animation known as cryptobiosis. It curls into a desiccated, lifeless ball called a ton, expelling over 97% of its body's water. Its metabolism slows to a near imperceptible crawl, less than 1/100th of its normal rate. In this state, it is no longer a creature of flesh and water, but a glass-like statue, a ghost of itself, waiting for the world to become hospitable again. And it is willing to wait for a very, very long time. From within its tun, the tardigrade can withstand a gauntlet of horrors. So it can survive heat and cold. But what about pressure? The kind of pressure that would turn a military submarine into a soda can. The tardigrade treats it like a gentle hug. It can withstand pressures 6 times greater than those found in the Mariana Trench. But the true test is radiation. A dose of 10 grays of radiation is fatal to a human. Think about that, the kind of dose you'd get from a catastrophic nuclear failure. The tardigrade endures over 5,000. You would be vaporized. The tardigrade simply waits. For years, these abilities were tested in labs, but in 2007, scientists decided to give it the ultimate test. They strapped a colony of tardigrades to the outside of a satellite and launched them into low Earth orbit. For 10 days, these microscopic animals were exposed to the naked void. They endured the hard vacuum, the unshielded solar radiation, and the freezing temperatures of space. When the satellite returned to Earth, the researchers retrieved their tiny astronauts, added a single drop of water, and watched in amazement. The tardigrades stirred. They rehydrated, stretched their legs, and crawled away, completely unharmed. Some even went on to lay eggs, which hatched into healthy offspring. They are, without a doubt, the toughest animals on Earth. Microscopic miracles that prove the line between life and death is far more blurry than we could ever imagine. But if an animal this complex can achieve near indestructibility, what happens when a much simpler life form, a single bacterium, masters a similar trick? A creature that doesn't just endure radiation, but allows it to shatter its very essence, knowing it can piece itself back together again. Conan the bacterium. Inside the cooling pools of a nuclear reactor, a place where lethal radiation rips living cells to shreds, scientists found something thriving. It was a bacterium so tough, it earned a spot in the Guinness Book of World Records, a microbe that treats a nuclear apocalypse as a minor inconvenience. Its name is Deinococcus radiodurans, but it's better known as Conan the bacterium. It was first discovered not in some exotic, radioactive wasteland, but in a humble can of ground meat. In the 1950s, researchers were testing radiation as a way to sterilize food, hitting a tin of meat with a massive dose of gamma rays. The blast should have killed everything inside, but the meat spoiled anyway. The culprit was this microscopic reddish dot, a single-celled organism with an unheard of will to live. While a dose of 10 grays of radiation is fatal to a human, Deinococcus can withstand an astonishing 15,000 grays, and in some experiments has survived up to 30,000. So how does it do it? Its secret isn't a shield, it's a superpower of resurrection. Most extremophiles work hard to protect their precious deoxyribonucleic acid from damage. Deinococcus does the opposite. It allows the radiation to ravage its body, to pulverize its chromosomes and shatter its genetic code into hundreds of disconnected fragments. For any other form of life, this is absolute death. For Conan, the bacterium, it's just the start of a miraculous repair job. Within hours of the assault, a team of specialized proteins goes to work. They hunt down every broken piece of deoxyribonucleic acid, match the fractured ends, and meticulously stitch the entire genome back together perfectly. It's like watching a shattered mirror reassemble itself without a single crack. In less than a day, the bacterium is whole again, ready to function and divide, as if its very essence hadn't just been shredded into oblivion. This incredible ability is paired with a resistance to dehydration, acid baths, and even the vacuum of space. This tiny survivor has mastered the art of rebuilding from total destruction, a biological phoenix rising from its own ashes. But while it has conquered the modern world's most toxic environments, other immortal microbes have been waiting in the ancient one. What happens when we unearth a monster that hasn't just been sleeping, but has been waiting, frozen, for 30,000 years? The Siberian plague sickle. Scientists drilling in Siberia spend months looking at mud. Thousands of feet of frozen, boring mud. They were looking for air bubbles, for climate data, for a glimpse into the past. But what they found sleeping in that mud wasn't data. It was a monster. In 2014, this team of French scientists drilled nearly 100 feet into the Siberian tundra, extracting a core of Earth that had remained frozen since the last ice age. They were hunting for ghosts, for biological relics from a time when Neanderthals still walked the Earth. And they found one. It was a type of virus the world had never seen, a titan from a forgotten era. They named it Pithovirus sibericum. The term giant virus is not an exaggeration. At 1.5 microns long, it is larger than many forms of bacteria, a behemoth in the microbial world easily visible under a standard microscope. For 30 millennia, it lay dormant, its complex genetic code perfectly preserved in the deep, dark cold. It was a fossil, a time capsule from the Pleistocene. But the researchers had a chilling question to answer. Was this ancient monster truly dead, or was it merely waiting? Back in the lab, they staged a chilling experiment. They introduced the thawed virus to a petri dish filled with modern, single-celled amoebas, a simple and harmless target. Then, they watched. The result was the stuff of nightmares. After 30,000 years of inactivity, the virus reactivated. Its ancient machinery sputtered back to life, and it began its deadly work, hijacking the amoebas and turning them into mindless factories to replicate itself. The prehistoric monster was still a killer. Thankfully, Pithovirus is harmless to humans. But its reanimation is a terrifying proof of concept, a warning shot from our planet's deep past. What other, more dangerous pathogens that our immune systems have never encountered lie waiting in that same ice? What ancient plagues are on the verge of being set free by our warming world? It raises the question of what death even means for a microbe. While some can be revived from a frozen slumber, one creature has found a way to avoid the end entirely by simply deciding to be young again. The jellyfish that hits rewind. What if death wasn't the end? What if, when faced with old age or injury, you could simply hit a reset button and begin your life again from infancy? For one tiny jellyfish, this isn't a fantasy. It is the simple, baffling truth of its existence. Meet Turritopsis dohrnii, the immortal jellyfish. Barely the size of a pinky nail, it drifts through the world's oceans, a virtually invisible creature that has managed to conquer one of life's most fundamental laws. Like other jellyfish, it begins its life as a tiny, free-swimming larva. It soon settles on the ocean floor, transforming into a plant-like polyp. This polyp eventually buds, releasing the familiar, bell-shaped adult medusas that swim free. For every other of the thousands of jellyfish species on Earth, the death of the adult is the end of the line. But for Turritopsis, it's merely an option. So what happens when it gets old? Does it just wither and die? Not even close. When this jellyfish is stressed by starvation, physical damage, or even just the onset of old age, it can perform an act of biological alchemy. Instead of succumbing to death, it initiates a stunning reversal. Its bell and tentacles begin to wither, not decaying, but being reabsorbed into its own body. It sinks to the seafloor as a formless cyst, a blob of living tissue. Inside this cyst, something impossible happens. Its specialized adult cells begin to regress, transforming back into the universal stem cells of its infancy. From this cyst, a new polyp grows, genetically identical to the adult that had just died. This new polyp will eventually bud and release a new generation of medusas, starting the entire cycle over again. It's not healing, it's a complete biological reboot. The adult jellyfish doesn't just escape death. It is literally reborn from its own cells, ready to live its life again. This cycle can, in theory, repeat forever, making it biologically immortal. While it can still be eaten or killed by disease, it holds the secret to cheating old age. This tiny creature has conquered time by creating an infinite loop of life. But what if the secret to immortality isn't to live forever, but to sleep for an eternity? A slumber so deep it can last for millions of years, waiting patiently inside a tomb of fossilized gold. The 40-million-year slumber. The image of a prehistoric insect trapped in amber is a window into a lost world. But the real story isn't the insect frozen in time. It's the invisible stowaways locked inside, passengers on a 40-million-year journey to the present day. In 1995, a biologist named Raul Cano was examining a Dominican stingless bee, perfectly preserved in a tomb of fossilized tree resin. This tiny creature last flew during the Eocene epoch, a time when the world was a warmer, greener place, long before the first hint of humanity. Cano had an audacious theory. What if the microbes in the bee's gut had survived the ages by turning into dormant spores, tiny biological fortresses built to outlast catastrophe? He decided to attempt a resurrection. They had the spores. But the real question, the one that could rewrite biology, was simple. After 40 million years, could they wake them up? Under meticulously sterile conditions, his team carefully drilled into the amber, pierced the bee's abdomen, and extracted a microscopic sample of its digestive tract. Inside, they found the spores they were looking for, belonging to a bacterium now known as Bacillus sphaericus. They placed these ancient sleeping cells into a nutrient-rich broth and waited. Then the impossible happened. The 40-million-year-old spores began to germinate. The delicate machinery of life, silent for eons, flickered back on. The bacteria awoke from their impossibly long slumber and began to grow and divide as if only a moment had passed. They had successfully revived a living organism from an era when the ancestors of whales were just beginning to walk on land. This creature survived by entering a state of perfect suspended animation, a deep sleep that defied the ages. But there are other microbes that survive not by sleeping, but by slowing their existence to a crawl, living a life so slow it's nearly indistinguishable from death itself. Life at the speed of stone. Journey 2 miles beneath the ocean floor into a realm of absolute darkness and crushing pressure. Down here, there is no light, barely any food, and almost no oxygen. It should be a sterile, silent tomb. Instead, it's home to a zombie ecosystem where life moves at the speed of stone. For decades, scientific drilling ships have been pulling up sediment cores from deep beneath the world's oceans, revealing layers of mud and clay that haven't seen the sun for 100 million years. For a long time, it was assumed these layers were lifeless. But when researchers in 2020 examined cores from the South Pacific Gyre, one of the most nutrient-poor regions on the planet, they found something astonishing. The sediment was teeming with living microbes. This was the deep biosphere, a hidden world of life locked away from our own. These creatures are not dormant spores waiting to be revived. They are awake and active, but they exist in a state of extreme slow motion. Starved of energy, they have slowed their metabolisms to a near standstill to survive. Think about that. Not sleeping, but living a life so slow, a single day for you would be like 10,000 years for them. What would a creature like that even experience? They might take a single breath over several thousand years. They can live out an entire millennium on an amount of energy that wouldn't even power a wristwatch for a second. Their lifespans are measured not in hours or days, but in geological epochs. They were born when dinosaurs ruled the earth, and have been living their quiet, slow-motion lives ever since. Buried alive under miles of water and rock. This discovery is more than just a curiosity. It redefines the very limits of life. It proves that life doesn't have to be fast or dynamic. It can be patient, quiet, and nearly timeless, a slow burn that persists for eons. These microbes survive by living on the absolute minimum, barely clinging to the edges of existence. But what if survival isn't about hiding or waiting? What if it's about becoming a predator of evolution itself, a master thief that steals the genetic weapons of its victims to ensure its own immortality? The billion-year-old gene thieves. In the ruthless game of evolution, sex is the ultimate survival tool, a way to shuffle the genetic deck to adapt and overcome. So, how has one microscopic animal survived for over 60 million years as an all-female species? It abandoned sex and became a master thief, stealing the evolutionary secrets of everything around it. They are the bedaloid rotifers, microscopic animals found in freshwater habitats all over the globe. For tens of millions of years, every single one of them has been a female, reproducing by laying eggs that hatch into perfect clones of their mother. To biologists, this is an evolutionary scandal. Without the genetic mixing that comes from sexual reproduction, harmful mutations should accumulate over generations, and the species should lack the ability to adapt to new threats. By all accounts, they should have vanished from the Earth eons ago. Yet they thrive. Part of their secret is a familiar one. Like the tardigrade, they are masters of suspended animation. They can completely dry out into a lifeless speck, capable of being carried on the wind, waiting for a drop of water to resurrect them. In 2021, a rotifer was successfully revived after being frozen in the Siberian permafrost for 24,000 years. But how do they adapt without sex? This incredible toughness hides an even more bizarre survival strategy. When the rotifer desiccates, its cell membranes and even its deoxyribonucleic acid can shatter. This should be a fatal injury, but for the rotifer, it's an opportunity. As it rehydrates and its cells become temporarily porous, it begins frantically repairing its own genetic code. In the process, it accidentally pulls in stray fragments of deoxyribonucleic acid from its surroundings, the genetic remnants of bacteria, fungi, or algae it may have consumed. And here is the masterstroke. It doesn't discard this foreign deoxyribonucleic acid. It actively stitches these stolen genes into its own chromosomes. Scientists have found that up to 10% of a bedaloid rotifer's active genes have been pilfered from other kingdoms of life. It's a creature that builds itself from a library of stolen evolutionary traits, taking the best survival tools it finds and making them its own. This creature survives by stealing the biological weapons it needs from others. But there is another kind of survivor, one that doesn't need to borrow anything. In the most toxic radioactive wasteland on Earth, it has evolved to do something impossible. It feeds on the fallout itself. The thing that feeds on fallout. In the dead heart of the Chernobyl exclusion zone, inside the concrete sarcophagus entombing the world's worst nuclear disaster, life has returned in a bizarre and alien form. Something is not just surviving the lethal radiation, it is actively reaching for it. It is eating the fallout. In 1991, 5 years after the catastrophic meltdown, a remote-controlled robot was sent into the ruins of reactor number 4. The radiation levels inside were so high that any human would receive a fatal dose in mere minutes. But the robot's cameras revealed something impossible. The reactor's walls were coated in a thick, slimy, black mold. In a place that should have been rendered sterile by the inferno of atomic decay, life was somehow thriving. It took years for scientists to safely retrieve and study samples, but when they did, they uncovered a secret that changed our understanding of life itself. The fungus was found to be incredibly rich in melanin, the same dark pigment that colors human skin and protects it from the sun's ultraviolet rays. But this fungus was using melanin for a far more radical purpose. In laboratory experiments, scientists observed the fungus growing faster when exposed to radiation levels 500 times higher than normal. It was performing a process they dubbed radiotropism. It was actively growing towards the source of radiation, like a plant craning its leaves toward the sunday. But how can radiation be food? The melanin was acting like a biological solar panel, but instead of capturing harmless photons of visible light, it was harnessing the immense power of gamma rays, one of the most destructive forces in the universe. Just as chlorophyll converts sunlight into chemical energy for a plant, this melanin was capturing the energy of atomic decay and using it to fuel its own growth. The very thing that made Chernobyl a wasteland was, for this fungus, a life-giving feast. This dark survivor has adapted to feed on our most modern poison, a chilling testament to life's relentless ability to find a way. But other microbes have endured a different kind of challenge, the crushing weight of deep time itself. What happens when we find a creature that has been not just dormant, but imprisoned since the world had only one supercontinent? The quarter-billion-year-old prisoner. 250 million years ago, before the Atlantic Ocean existed, the world's continents were fused into the supercontinent Pangaea. The first true dinosaurs were just beginning to walk the Earth, and in a shallow, evaporating sea, a single bacterium became trapped in a crystal of salt, beginning a prison sentence that would last for 250 million years. The discovery was made in the year 2000, in a place as timeless as the creature itself. A cavern nearly 2,000 feet beneath the New Mexico desert, carved out to serve as a permanent tomb for nuclear waste. Geologists were studying salt formations from the Permian period when they found it. Trapped inside a pristine salt crystal was a microscopic bubble of fluid, a tiny, preserved droplet of that ancient ocean. And inside the bubble, they saw a speck. It was a long unseen type of bacterial spore. The question was a mind-bending one. After 250 million years, could it possibly still be alive? The experiment to find out was one of the most delicate in modern biology. The risk of contamination from modern microbes was immense. Under conditions of absolute sterility, a team led by Russell Vreeland carefully shaved away the outer layers of the crystal. They pierced the microscopic bubble with a superheated needle, drew out the ancient brine, and placed it in a nutrient-rich culture. For weeks, the sample sat inert. The team waited, doubting what they would find. Then, the impossible happened. The spore, which they named Bacillus permians, reanimated. Its life-sustaining machinery, dormant for eons, flickered back on. After 250 million years of suspended animation, the bacterium awoke and began to divide. The discovery was so profound it was met with intense skepticism, but rigorous testing confirmed its authenticity. This was no contaminant. It was a true living fossil. It had survived the rise and fall of the dinosaurs, the shifting of the continents, and the entire span of human evolution, all while locked away in its crystal tomb. This prisoner of the salt proves that life can wait for an almost infinite amount of time, surviving in a warm sea that became its tomb. But what about the other extreme? What can we learn from a creature that survived not in salt, but in the crushing, absolute cold of a 2-mile-thick glacier, a survivor that points to where we might just find life on other worlds? The survivor in the ice. 120,000 years ago, before modern humans had even left the continent of Africa, a single bacterium was flash-frozen inside a Greenland glacier. It remained there, entombed in ice under immense pressure, until a team of scientists drilled 2 miles down and brought it back to the surface. And then, after an ice age of slumber, they watched it wake up. The discovery was made deep within an ice core, a cylinder of ice drilled from the Greenland sheet that acts as a frozen timeline of Earth's climate history. Scientists from Pennsylvania State University were melting these ancient samples, expecting to find only trapped gas and mineral dust. Instead, under the microscope, they found something moving. It was a species of bacterium unknown to science, which they named Herminiamonas glaciae. This was not a spore that had simply waited in a dormant state. The evidence suggested it had been actively, if slowly, living inside the ice. For this creature, survival was a monumental challenge. It endured temperatures that rarely rose above freezing, and the crushing weight of over 10,000 feet of ice. To stay alive, it adopted a unique strategy. It shrank. This bacterium is 10 to 50 times smaller than the common Escherichia coli found in our gut, a form of dwarfism that allowed it to survive in the microscopic veins of liquid water that can exist between the crystals of ice. It lived in the cracks of a frozen world, subsisting on the bare minimum of nutrients trapped alongside it. After its 120,000-year ordeal, the researchers gently warmed the microbe in the lab. They kept it in a low-oxygen, cold environment for 7 months before they saw the first signs of growth. After a full year, a colony of tiny, violet-colored organisms had formed. The survivor from the Ice Age was alive and well in the 21st century. This tiny, tenacious life form is more than just a biological curiosity. It is a profound message from our own planet. It proves that life can endure for geological ages in environments we once considered utterly sterile. The survivor in the ice suggests that if we want to find aliens, we may not need to look for distant, Earth-like worlds, but in the cold, dark, and seemingly dead places much closer to home. These creatures teach us that life isn't a fragile spark in the darkness. It's an unquenchable fire. And the question they leave us with is not just, are we alone in the universe, but is a part of us, the very will to survive against all odds, already out there, waiting